Um, as the as I have been presented, my name is Mfundi Erasmus Songo. I'm in Eskom, and my area of specialization is focusing on technologies, blending power systems. Currently, I'm busy with the BESS as well as microgrids. In my presentation, I would like to give you an outline of how the skills currently in the country that we have, where we develop them, and how we have applied them, and how we have evolved. I will use the power systems analysis, designs, and innovation in applications in the battery energy storage systems and microgrids. First of all, we have to understand the evolution and development of skills, of skills, not as skills. How do I come to define this, and why am I presenting it in this format? I'll start with the nucleus, the heart of where one actually becomes a skilled person or is labeled as a skilled person, and where they start and how they end up being an expert in their respective fields. When we have graduates from tertiary institutions, whether they are engineers of the IT or from the legal department or accountants, they are all energetic. They've got theoretical knowledge. They can do calculations up to the last decimal place. Even if it's 10, they will write them. And they're all over the shore. They want travels, sites, and people. They're unsettled. They've got many change. They may change even their focus. You can have an engineer who ends up becoming an HR manager. They are free-spirited. But in so developing, we move to the next level, which is the professional bodies, where if you see everything is underlined there, you now get into a level where now you are told, don't toe the line. You learn to be independent, but at the same time, you must follow all the T's and dots and crosses. You become a member of the professional bodies such as EXA for some of us who are PRN professional engineers, or the SI Geospace, SAGC, and so forth. Yeah, the professional has got a clear path in scope definition. They've got order, they've got principles, they know what they're supposed to do. It's more like routine work. It's like being a teacher. We all know we are all products of teachers. So we know what is done. But in the respective fields, and in this case, in engineering and the electrical power systems, you have to have a clear path and understand the scope definition. What does it mean? What are the principles? And in so doing, as an individual in your own development, you can now name and associate with projects. I finished this, I designed it, I surveyed, I was part of this. You get through the awards and recognition. You go through presentation forums. You're excited about them. That level is where one is really working hard. They almost work 24 hours because they are dreaming. Every day they work, they think about this work. It's their life, they live it, they understand it. Now, when we move to the next level, this high level is that one becomes, which is the expert, where one becomes an industry leader. In other words, one looks at the strategic level of business. How does it work? And then one starts working smart at this league. There comes a point where there is peer recognition. You are called a fellow, you are called a certified engineer, you are called a director, you can be called an associate professor, a professor. Or if you've done well in the business sector, you can be called an entrepreneur. Of course, with all this experience and so forth, there comes a stage where now one is giving back. You can now sit and relax and coach and mentor, because you know now how to play the game of chess, or how to do you can easily find out what is the problem, what is the issue by the rule of the thumb. That's what people say. And one becomes more open and honest about what is it that they know. So you can always say, let me refer you to the expert on this and that, which is where some of us are almost getting to that league where we'll say, okay, if you want to go and refer to power systems analysis Just look at Medupi. It's my hand. It's all the power lines. I designed them from scratch. Just look at the Rustenburg platinum mines. At that stage, you are more comfortable with what we are doing. You can be asked any question at any time of the day without even referring to the dots and lines, which is what we have, which is what you'll be doing in the second phase. Now, why are these stages relevant, and why am I presenting them? It is simple because when we look at the projects that we have as Eskom and as a country, we've got the concept at a high level. We've got the concept, design, execution, maintenance, and operate. And then to come to the obsolete when the project dies, or it's like the old power stations that are being mothballed, or they are being completely transitioned to just to gas or to solar PV plants. At the concept phase, we look at what is the issue, what are the needs, what needs to be done, what needs to be solved. That is where we can have a lot of ideas, dreams, and vision. A young engineer who's just started or who's just getting into the professional world will have a lot of concepts that they can write about because they're dreaming about seeing things happening. When it comes into the designing, this is existing, these are new, we've got standards. Are we going to have a new design? What standards are we going to apply? What groundbreaking technology are we going to have, like BESS and microgrids? And when we execute, what type of equipment are we going to use? Who will do what? Technology and environment, cost and budget. We are realizing what we dreamt about. We've got celebrations, but at the same time, we've got disappointments. There are some concepts that we would have thought about, that we had a lot of good ideas, but that don't work out like that. Then we move to the maintenance and operations, where we hand over projects which are finished, where there have been improvements. We live with them. We now understand that it is not what we thought about. It is what it is. How do we hand it over to the clusters? How does the system operator react? Who are the people that run to site? How does the community react? We've got a crisis, a national crisis of vandalism. Now, that leads to what happens next. We've got old batteries. Well, we're talking about BESS now. In a minute or so, I'll be wrapping up. We've got chemicals that come out of that. What are we going to do with that? Those are the challenges that we're facing. And across this value chain, we've got a number of skills. If I go back to where we are, we've got a lot of youngsters that are energetic that will be filling in these positions, and we've done that. When we started the BESS project, we had no one who understood how BESS works. We had no one who understood how BESS designs worked, but we had professionals and with experts and with people that understood chemicals and the like. We integrated all this, and then we ended up coming up with the construction projects. Progress, for example, as I'm talking about, we have the current project, which is the Elan Scope in KwaZulu-Natal, the whole value chain that I spoke about. These are all skills. These are all, in terms of the surface leveling and the like, this is routine work. But in terms of the skills and planning for this, the chemicals that will be spewing out of the batteries, how they will integrate into the network, how the power system will behave, was all worked into this. And then we look at the construction, which is progress, which is Pongola, the site clearance, which is what you know about. And then we come to the end product, which is a complete BESS site, which is the HEX 20 megawatt, 100 megawatt hour HEX, which was done in October last year. Why am I putting this as an example? It is to show you what we've done over the past 18 months, from concept, planning studies, designs, implementation, to handing over a project. This is how this project looked like when we started, which is what you see there. Exactly as you can see, the far right side here, the topsoil removal. This is how it looked like. This is how the ground looked like, though it's HEX. And now you come to this, which is the end product, which looks ideal, it looks well, and it delivers into the network. When we look, this is the major project, which is the battery energy storage project, the first of its kind in the continent, which is working. We have got the system operator who is working on this, who talks to what it does. It dispatches as and when it's required. I can just highlight a number of things. Most of you know this. This is a transformer, which is the step-up transformer. And these are the batteries right there. Can you see my mouse? I'm not used to this platform. Can you see my mouse? Yeah, these are the batteries. This is the power conversion system. This is the transformer step up, and this is the junction box where now you are now sending power into the control room, and then now the microgrids. We also had the microgrids, which has a small size of power system that we supply into the network. Which are all working in kilowatts up to about, we started about 16 to 25. We had one in the Northern Cape in Swartkop Dam, which was publicized in last year, July, which is 2 by 32 kilowatt and 120 kilowatt hours, where we assembled it. We started them from scratch, the designs, the concepts. We started by system analysis, and this is where it is. And with that, I think I've taken enough time. In terms of where we are, what has transpired in this evolution? We had no knowledge about, we had theory about how battery works. We now have got a solid foundation. We've got people that we have skilled on the designs, on the planning, on environmental, as well as construction. And right now, we are learning on how to commission and integrate BESS. And that is where we are now in terms of solidifying. In a number of years, 2 or 3 years, because we've got a 5-year maintenance and operation plan that we have, we will now be having experts. And these are all in-house. And even right now, when we talk about power systems analysis for microgrids or for BESS, we have used this evolution path in having these skills. We started with no skills. We currently have a pool of power system analysis engineers that can deal with BESS, plus minus more than 10. We started from 0, but we've got an expert, 2 or so, that are actually skilled in this. And these are skills that are upcoming, and that is where youngsters should focus on. Whether they're in tertiary institutions, they were never there. We've interacted with the tertiary institutions. That is what we should be focusing on postgrads and the like. And eventually we'll get there. With this, I would like to say thank you.